Student, can you hear me?
Yes.
Yes.
Yes, that's great. How's going? Everything okay?
So far, so good. Thank you.
Okay, thank you. Okay, so today, today's topic is BCI application. I'm going to show you some BCI application. Okay, and let me remind you that. Give me a second. Highlighter. Okay, so please complete the student feedback survey by today. Okay, and next week we will have a talk by Professor T.P. Zhou of UCSD. So during that talk, there is the final assignment. Okay, I will show you later. Okay, and later I'm going to show you the marking, and the details about your final project. Okay, and then today's topic, BSAT application. I'm going to show you some medical and non-medical application. For medical application, show you some motor and cognitive restoration, rehabilitation, and the communication, and how to use the B-side to control a wheelchair. Okay, and later I'm going to show you some non-medical application. Okay, and first I'll begin with a paradigm, a classical paradigm called rapid speed visual potential, SVP. And later I'm going to show you how to use this SVP to develop a lie detector. Okay, basically based on a BCI system. Okay. So first, Professor T.P. Zhou's talk next Tuesday, and starting from 1:30 to 2:30. Okay, an hour-long talk. Okay, and you can find some information about T.P. Zhou from his website. Okay, and then the marking. Okay, the midterm 30. Let me change the color. Sorry, give me a second. Change the color. Pen. Right. Okay. Okay. For our midterm, 35. Oh, 30. I have to write slowly. 35%, and our final project 45%. So from now we have totally 6 assignments. Okay, with different points to our 5. Okay, till now we have. Sorry about that. Okay, till now we have 18 points for our assignments, and next week we are going to have a in-class activity. Okay, I encourage students to ask questions to our speaker, Professor T.P. Zhou. Okay, and Each question is worth 2 points. Okay, so 80 plus 2, or 2, sorry, 2 points. Okay, you can ask question to Professor TP Zhong. Okay, and please don't forget that you have to leave your question here. There's a Google Sheet. Please leave your question here. Okay. And let me know who asks who asked the question. Okay. So any question for our marking? Okay, so 20 for our assignment, 35 for midterm, and 45 for our final project. So let's go to our final project. Here show you some details about the final project, 45%, and I need to correct it for the data collection. Okay, several weeks ago, I told the student that if you collect the data by yourself, then you can get 7 points. Okay, I mean maxima. At max 7 points. And if you download, okay, use the data set from some website, 2 marks. Okay, but okay, this is the 2 plus 5 marks. If you select to use the database, okay, from some website, you are going to complete your final project by using some public accessible database. It's fine, it's good, but here's some criterion for you. 2 marks. You need to describe the experimental design paradigm, basically to describe the procedure of the collecting, okay, how this data set will collect, okay, and show us the hardware, software, data size, basically number, some data description, okay, so, for example, number of channel, sample rate, how they processed the data set, okay, and the website your data set download from, and the owner, basically the research institute who collect the data. Okay, 2 marks and 5 marks. Okay, you need to evaluate the quality of the data set and try to justify the data source are reliable. Okay, it's very important. For example, you can survey some existing literature to know which research, to know which study used this data set before. Okay, so any question for these 7 points? Okay, so basically you can collect the data set by yourself or download the data set from the internet, but you need to provide some information about the data set. Okay, some data description and justification of the data set. Okay, so 7 marks for data collection. Next, again, you don't need to prepare any presentation slide. Okay, but student need to build a GitHub to create a GitHub page. Okay, and with a very short video, maybe 1 minute to 3 minutes. Sorry. 1, 2, 3. Oh, terrible. Highlighter. It's much better, but it's yellow. Okay, to build the GitHub page, 10 marks, 1 to 3 minutes for your demo video embedded to your GitHub page. Okay, and here I provide 2 GitHub page for your reference. Okay, so 10 marks, 5 marks. Then here 23 points. Okay, for your BCI system. You need to show me the framework of your BCI system, such as the I/O, what's the input, what's the output, signal preprocessing, processing, data segmentation, artifact removal, feature extraction, machine learning model, etc. Okay, and the second one is, do you have any competing method? Okay, and do you need to perform some comparison? For example, the performance of your BCI system used with artifact removal techniques or without. You can perform some comparison. And you can conduct several analyses, such as time frequency analysis for your data set. Okay? And third, validation method and metric. Okay. At the end of your GitHub page, I think you need to provide some results. Okay. I need to show me what validation method you used, like cross validation, K-fold or leave one subject out, etc. And what metric you used, like accuracy, confusion metric, or ROC, okay, etc. So 23 points for your BCI system. So data collection 7, your BCI system 23, and GitHub page 10, and video 5. So 45 points for your final project. So any question from students? Oh, by the way, if you want to discuss your final project with me, you can make appointments. Okay, we can have a chat online or in person, but make a point. Okay, so let's go. So don't miss out the talk next week. Okay, and there's an in-class activity 2 points. Your question is worth 2 points.
Professor, just a quick question about in-class activities.
Mm-hmm.
So we just have to type question in Google Sheet, the link that you provide, right?
Mm-hmm.
Okay, thanks.
Yes. During the talk, you can think what question you want to ask to our speaker.
All right,
Okay,
thank you.
and then you can turn on your microphone, and then don't forget that to leave the question on the Google Sheet. Okay. Any question for the final project? So it's 45 points. So you need to, I think you need to start and to prepare this. Okay. If you have any problem, okay, please email me. We can make appointments to have a chat.
Professor, when is the due date? I imagine it's the last week, right?
Pardon? Last week. Yeah. Week. Basically week. The due date is week
18, I think.
Yep.
Thanks.
All right. Okay, so let's start our lecture. First, I'm going to show you some medical application. Okay, so we know that the field of BCI originated with the goal of helping like paralyzed and disabled. So it is not surprisingly that some of the major applications of BCI today have been in medical technology. Okay, particularly restoring sensory or motor function. Okay, some sensory or motor function. Sensory, let me highlight it. Sensory and motor function. So one of the most widely used commercial BCI is cochlear implants for that. We have talked about that in our first or second lecture. As are retinal implants being developed for the blind, the cochlear implant is an example of a BCI for sensory restoration. Give me a second. So there has not been much research. Oh, by the way, may I ask a question? I said that for BCI, it's easy. Well, actually, not easy. Most of the medical application, they build the system and try to restore sensory and motor function. So my question is, how about this? How about the somatic sensation of action or task? Can BCI restore these three types of, can I say, problem: sensation, reflection, and test? Actually not. There has not been much research on these three types of purely, I say purely sensory BCI. So in the case of, for example, in the case of somatosensation, the need for, I think the need for BCI is minimized in somatosensation, because I think it is often possible to restore tactile sensation through like a skin grafting. Okay, so some skin grafting instead of a BCI. Okay, however, there is but I admit that there is a considerable interest in somatosensory, stimulation, somatosensory stimulation to allow us to sense object being grabbed or touched by prosthetic device. Okay, we are interested in, can we produce some somatosensory stimulation for this? Okay. Okay. And how about the olfaction and test? Okay. In the case of BCI for olfaction or test, I find that there have been an effort to build like an artificial nose and chips, and that can sense various type of odors. But compared to the population of like visually or hearing impaired persons, the legs of a large population of individuals in need of such BCI. Okay, I mean the need for olfaction and test. Okay, making the lack of interest in developing such BCI for these two type of purely sensory. Okay, due to the lack of large population. Okay, so most of BCI system focused on visual information to restore the visual information, motor, or what else? Basically, auditory. Okay, these three, but not olfaction, test, or somatosensation. Okay, so motor correction. Another major motivation for this field is that research over the last 3 decades has been the goal of developing prosthetic devices for individuals that can be controlled using neural signal. Okay, and perhaps closest to being commercialized prosthetic. Try to develop some prosthetic arm, and this arm can be controlled by nerve signal from the brain. Okay. So yes, we did see some BCI for motor restoration. And further into, further into the future are prosthetic arm and hand, and that can be controlled directly using cortical neuron. Okay, instead of a nerve signal. That's different. Okay. We did find some device, okay, the BCI device that can be used for motor restoration by nerve signal. But I think that in the future we can see some BCI they use cortical signal, okay, instead of nerve. And perhaps the most challenging to realize are lower limbs prosthetics controlled by like brain signal, like EEG signal, collect the brain activity brain signal collected from the scalp. So in this case, the BCI system need to be able to maintain stability and allow the user to maintain a balance while obey command from the brain and provide maybe providing some feedback by stimulating somatosensory neuron appropriately. Okay, so this is motor restoration. So cognitive restoration. Okay, I like this. Okay, I think BCI could be potentially be used to treat a number of cognitive neurological disorders. For example, we know that several groups are working on methods and to predict seizure, okay, or to detect their onset, the onset of seizure, okay. So this is a picture I download from Google seizure. So you know seizure, right? A seizure is a sudden and uncontrolled electrical disturbances in the brain, and seizure can cause change in your someone's behavior, a movement, or feeling, and some maybe cause some change in level of consciousness. And a seizure affects approximately, I think, 50 million or more people of all ages. Okay, so it's the second seizure is the second most common neurological disease. So do you know which one is the first most common neurological disease? Headache. The headache. Okay, headache is the first, and seizure is the second. Okay, the seizure affects about 50 million of people. Okay, so I think a lot of research group try to use the BCI to detect the onset of seizure, so as to prevent it. Okay, if we can detect the onset of seizure, that means we can provide some appropriate medicine drug, okay, to prevent it, okay, to spread to other parts of the brain, okay, I mean the seizure. So for those group, I think the early seizure predictions is crucial, and several studies have shown that the onset of a seizure generally this figure show you the EEG data from a patient with seizure. So you can find that there are some important phases like pre-ictal, inter-ictal, and onset Okay, or someone call it ito stage, and the onset of seizure. So this phase is ito phase, and then post ito. Okay, so let's look at this pattern. These are all EEG pattern. Okay, so a lot of research show us that seizure generally follows the characteristic prehisto period. Okay, so you can find that the EEG pattern here, prehisto period or stage or phase, the EEG pattern is quite different from the patterns of seizure here. Compare this, the pattern here with the pattern here. You can find there's the pattern is quite different. Okay, and there is another important message here. Oh, let me clean. Sorry. Here. The pattern of the EEG pattern of ito phase. The EEG pattern of pre-ito. Yes, as we see, this pattern is very different from here, and also very different from the pattern of pure preceding, I mean the pre-ito stage. Okay, so as an engineer, if you want to build a system and this system want to use the EEG pattern to predict the onset of seizure, what's your design? If I want to build a BCI system that can be used to detect the onset, or I think that's not detect, to predict the onset of seizure. I think there are two EEG patterns I'm interested in this, the pre-ito and ito. Okay, so I think being able to distinguish pre-ito and inter-ito, because if an EEG pattern change from pre-ito to ito, okay, then we know that there will be a seizure follow the inter-ito stage, right? So I think my BCI system, if success, I think this system need to be able to distinguish pre-ito and ito data pattern. Okay, so this system can predict the seizure. Okay, if my system is successful, I think such method could be incorporated into a BCI that monitors the brain for the onset of a seizure and when the onset of a potential seizure is detected. So we can try to deliver some drugs or to this. This is instead of the drugs, you can deliver or to try to stimulate the vagus nerve to stop the seizure before it spreads to other parts of the brain. Use this device, okay, attached to your neck to deliver some electric signal to the vagus nerve. Okay, and this has been proved. This stimulation can stop the seizure. Okay, so once I detect my EEG pattern change from pre-ictal to ictal, let's indicate we need to deliver some drug or try to stimulate the vagus nerve. Okay, so basically this is the idea of seizure prediction system. Okay. Now I'm going to talk about the rehabilitation. Another potentially significant application, I think, in BCI field is in rehabilitating a patient recovering from like stroke or surgery or other neurological condition. And the BCI would be a part of a close, like this one, a close. If you want to build a BCI, and this BCI can have some function like a rehabilitation, then you need to make your BCI like a closed loop feedback system. So this is this one is a typical closed loop system, the framework. The brain is here. The brain is there clear signal. Okay, here. Signal acquisition, brain activity is recorded and digitized the field, and the relevant feature you can extract in like real time and translate it into some device command. Okay, and you can provide some form of an online feedback to the end user. Okay, to this end user about what they achieve with their brain response. So the patient can learn how to control their brain activity. Okay, manipulate their brain activity. Okay, so such a neurofeedback system can enable patient to learn to generate the appropriate types of neural activity. Okay, so we think our hypothesis is if we can learn how to generate appropriate type of neural activity, okay, and that patient can accelerate their rehabilitation. Okay, this is the idea of the closed loop system. So I want to mention more about the stroke. Okay, in previous slide we talked about the seizure, and stroke is one of the main root cause leading patient unable to comfortable control their muscle and body in daily life, and even lose the ability. So a stroke, sometimes we call it a brain attack, occurs when something blocks blood supply to parts of the brain, or when a blood vessel in the brain bursts. It's quite dangerous. Okay, imagine that someone's blood vessel in the brain burst. Wow. So in either case, parts of the brain become damaged or die, or they can result in lasting brain damage and some long-term disability or even death. Okay, it's horrible. So we know that the ability of the body controlling in. Okay, give me a second. Okay, we know that Suppose we know that the ability of body controlling is inversely proportional to the distance between brains and limbs. Okay, our ability, the body control is inversely proportional to the distance between brain and limbs. So that is, the longer the distance is, okay, the lower the ability is. So motor function of injured angle, like this one, injured angle. This patient with injured angle. Okay, so motor function of injured ankle will be recovered more difficult than one of the hands with a similar disability. Okay, compared to hand. Okay, so this figure I copied from. I forgot I forgot to give you the information about this copy from a journal paper. So this paper, they are trying to build a B-side system for ankle rehabilitation. Okay, and research they built they call it a plate phone based robot, like this, a plate phone based robot. Okay, they use it. They call it a robot because they try to use this robot to release manpower. It makes sense, right? A robot to release manpower for ankle rehabilitation. So when training on this robot, the patient trained with this robot, the patient are normally normally in a sitting position like this, sitting on a chair, to train their physical function of muscle stretching or joint rotating. Okay, so basically this the patient are requested to activate the robot to track target by allowing the foot to follow visual or auditory instruction. Okay, because it's a robot, we need to deliver some command, allow the robot to track some target. Okay, so in this study combine here. Do you see this? A full circle on the screen. Actually, this study they use SSVEP to construct an information transmission loop between brain and robot. Okay, to enable patient to actively conduct the training. Okay, because we need to send the command to the robot, and they combine the SSVP to send the command for the patient. So the patient sit on a chair, some comfortable chair. It looks comfortable. Okay, and are requested to gaze at one of the flicking circle. Okay, basically SSVP. So the motor intention are detected through analysis, the SSVP signal. So each detection would immediately trigger this robot to conduct some predefined passive stretching. Okay, the robot will do this stretching for the patient. Okay, so I call it a passive stretching. Okay, to do some ankle rehabilitation. Okay, for the patient with stroke. Okay, it's 2:16, so how about take a 10 minutes break? We'll resume the class, okay, at about 2:25.
Okay. Thank you.
Okay, thanks.